Okay, so welcome back everybody. So remember, this video is going to be different than a normal video, right? So this first one is just an introduction. It's going to be our little pilot, if you want to think about it. It's our practice. And so the method of this video is going to be simply, what do you want in class? We can have the traditional method, which is what we did already. Basically what that is we come into class, we talk story, I write it on the board or the screen for you. And we do it like that. Traditional, we discuss it, I send you on your way when we're done. The alternative, which is what we're going to practice today, and we're going to take a little poll later, is this. I'm going to pre-record everything, do what I can. I'm going to try to truncate them into small clips, about 10, maybe a little longer, maybe sometimes shorter, depending. Why I do that is because of time, and time, if you sit there for a long period of time, you just have a hard time focusing, right? It's just, you just start losing focus. You're there for like an hour, like, oh my goodness, this is taking forever. So what I try to do is I try to do them in clips, so you can just watch a clip, come back to it, you got your focus for that clip, you come back to your next clip, you got your focus, come back to the next clip. And so remember, this is you telling me what you want for class. Okay, so if we took where we just left off, and we just left off about inferences versus, right, observations. Okay, so what's the difference, right? So an inference, again, is going to be something from prior knowledge, okay, which means you have to have known this to make some kind of assessment, right? Oh, it's a basketball. Well, how do you know? Well, it's orange, it's round, has lines on it. But because you've seen it before, you've seen them play a game, you've played a game with it once or twice. Observation is not. They are from your 5 senses, right? So it doesn't matter where in the world you are, based on your prior knowledge, you see the same things, you taste the same things, you touch the same things, you can hear the same sound, and you can smell the same aroma, right? Those are your senses. That's totally different than, well, I smell the cookies, just because you smelt them before, but somebody else may have never smelled cookies before. So that's prior knowledge. It smells good, no matter who you are, but prior knowledge, okay? So, what we're going to do is we're going to talk about this point of spontaneous generation, right? So what spontaneous generation is, if you think about spontaneous, it simply means what? It means instant, right? This term generation, we're going to focus more so on next semester, but it's an interesting word. It means kind of like coming down from generation to generation. Well, what is that? Because I'm kind of using the word in a definition, right? So, think about this. You got your grandparents, right? They came down, they gave birth to your parents. So your grandparents are first generation, your parents are second. They gave birth to you. You are third generation. What about you if you decide to have kids? Fourth generation, and so forth. So it's kind of like a lineage, like your hierarchy, kind of like your family life, okay? So when it says spontaneous generation, it means that you have made instant family. So pretty much means that you made life from nothing, okay? So that's what this says here. Life is coming from nothing or from something that is a non-living material. Now, this is an idea. Now, of course, it's an experiment trying to prove this, because now you got to think about this for a second. What we take for granted today is not what they took for granted back then. For example, this experiment. Back in the day, people thought that there's probably some worms or some other things already living in your meat. They didn't know about flies, they just knew they happened to be around. Just like they didn't know that fleas carried the Black Plague, right? With experiments and learning and education, we all learned it later. But remember, in the past, we had to figure things out. It wasn't like it was given to us. So bear with the experiment when you understand that it's a process of proving it versus, well, I already know that. So again, we're trying to talk about the process and how we solve the problem. So this is talking about how do we set up a controlled experiment. So for a controlled experiment, what we need to do is we have to first start off with a few observations. So we notice that if flies land on meat and they are left uncovered, maggots usually appear on the meat later. It's like, oh, okay, that makes sense. All right, not too bad. So here's our thing, right? We have our observation. We noticed that if we left flies uncovered over several days, we noticed that maggots would appear. Okay, so now, is it a coincidence? Now, we know maggots are from the flies, but wipe off every inference. We're trying to base it on observations, just what you can see, the data you collect, and evidence that you discover. So here's our experiment, right? We have an idea. Maybe flies come drop the maggots off. Okay, so that's our hypothesis. So what do? We got to run an experiment. So here's our control, right? We have our variables. Our controlled variable are things that are always the same. You're going to notice that, let me erase this little thing here, that the meat, for example, is the same meat, right, as the experiment. Why? Well, what happens if we use steak here, but this is going to be fish? Well, what happens if the fish doesn't have maggots? Is it because the fish, or maybe doesn't have worms, or is it because the flies don't like the fish? And you know, there's so many different variables. We want to remove any kind of randomness that could happen. So what we did is we don't use the different types of meat, we use the exact same meat, right? So we have the same meat. We have the same size jar. These are all our controls. We have the same temperature, right? Because we're not going to put this guy on the right side into the refrigerator, right? The temperature affects it. So we want to leave everything the same. Same meat, same temperature, same flies, same area, same everything, right? So we even having the same flies. The experiment that we wanted to do for this was simple. We have our manipulated variable right here. This is going to be the difference between the two. Does it have a cover or does it not? All right. So again, what I mentioned earlier, let's see if I can draw this nice straight. The controlled variable is something that you keep the same, right? Like I said, the jar, the type of meat, the location, the temperature, how long you ran the experiment, all those things are the same, right? And then we talk about the manipulated variable. The word manipulate means to change, right? So what did you change? Well, what we did is we added a cover. And it says over here that we added a gauze, keeping the flies away from the meat. Okay. And then what we do is we have our responding variable. This word responding here is saying, well, what happened? How do you know if the experiment was effective? How did you know that it worked or didn't work? Well, the responding variable in this case was, did maggots appear? And that's why we have this guy here as our control, as our normal. On normal circumstances, when flies come with the meat, over several days, we will have maggots appearing. Okay, so let's test that out. What we'll do is, hey, we have flies, we have the same meat, the same jar, however, we will cover it. We cover it. We have the same amount of time, we have the same amount of space and temperature, same fly, same everything. And after a few days, what we do is we notice no maggots appeared. So what does that tell us? Well, that gives us the conclusion that the maggots came from the flies. Now, again, I know you kind of already knew this, as you know, because we take education and our intelligence for granted. But remember, it's a process of how did we find this out? Okay, moving forward. Right? This is a different guy's experiment talking about how, okay, what about this? Well, we have gravy, right? We love whatever gravy you have. Oh, I left out my gravy for about 5 days. I went camping and I came home. What happens? Well, when it says teeming with microorganisms, English, you got all this fuzzy stuff, also what we know as bacteria. Now, they didn't know what bacteria was back in the day. However, they knew that there was stuff growing in there. Okay, so bear that in mind. Now, we have gravy being boiled, the flask being sealed. What does that do? That stops the air. Okay? That stops particles from getting into this bottle. So what happens? Air is unable to get in, which also means those microorganisms are not able to get in. So now what? Because we have sealed that and they are unable to get in, gravy is free of those microorganisms, also known as bacteria. Now, I do apologize, I do have sloppy handwriting, but it is what it is, right? And it's one of those gifts or curses, whatever you want to think about it. Alright, moving on. Okay, And the experiments, we have different types of variables, right? So I'm going to skip this because we have these already in your PowerPoint, and we're going to talk about them more so in class. But I want to get to this because this is important. Metric system is different than our US standards measurements, okay? We know that metric system, you can have meters, you can have grams, you can have liters, you can have all that stuff. We don't have ounces, right? We don't have pounds and all that. But let me make it easier for you, okay? Let's talk about something you know. Let's talk about your friend and mine, Mr. Cell Phone. Okay, so your cell phone. Most of you have an iPhone or some sort of smartphone nowadays. I mean, unless you have a flip phone, but then just look at your iPad or computer or whatever else, or your friend's cell phone. But we're going to use that. Now, in your cell phone, how is it measured? Well, if you have the base model, can go anywhere between 16 and 32 gigs, right? You heard this word. It's like, no, I have 128 gigabyte, right? Mine, no, I have the bigger one. I have 256 because I take a lot of pictures, blah, blah, blah. Okay, I'm not going to talk about that number. What I want to talk about is that term, a gig. Okay, you heard it before. Okay, now a gig, we know if we wanted to go smaller than a gig, and you looked at your standard files, maybe, and I'm going to write, this is going to be like storage, right? Let's just say a song. Well, how big is a song? Well, songs are not a gig long. Your movies would be, if you recorded a full-length iMovie with videos and pictures and it was long, yeah, it would be a gig easy, maybe even longer. However, a song is not. A song is in the megabytes, right? Right? So we got a GB for gigabyte and megabyte. And what's smaller than a megabyte? Okay, well, if you got a song, let's go smaller than that. Let's go with something like, back in the day, you have a really tiny 2-print PDF or some small file. We will have it called a kilobyte, right? Or KB. Okay, now, these all you've heard of before, you use very easily, but it's the same system that we're going to be using in class because all it is 10 to the 3. Okay, English. Let's translate it out for you. So here we go. All right, so 10, I'm going to put this in the middle, so 10 to the 0 equals 1. That is equal to, let's go at something, let's not use byte this time, let's use something as far as the length, let's go with meter. Okay, so let's just go with 1 meter, okay? And we're going to go up because we want giga, and I want to go with what you know first, okay? Now, if we have what we call 10 to the 3, this 3 is represented as an exponent, okay? And what that's going to do is it's going to, I like to remember, well, how many zeros are after the 1? Well, 1, 2, 3 zeros. So if I have 1,000 meters, right, that is equal to 1 kilo. So 1 kilo is 1,000. Okay, pretty simple. Well, let's go with this. Like I said before, let's go by another 3, 10 to the 6. So how many zeros is that? 6. 1, 2, 3, 4, 5, 6. Okay, so we got a million here. Now, that is a million meters. Okay, so what is that? That is, now it's not a kilobyte, it is a mega. Okay, now, we're not going to use these in class, but I like it because it reminds you of what we use every day on your cell phone. So I'm going to go a little sideways here. What is, the next one is 10 to the 9. You notice it's 3, 6, 9. This is going to be 9 zeros, so it's going to be fun. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is called a what again? You're right, giga. Now, for you computer junkies like myself, where I like a lot of storage, I play games, I have movies, all that other stuff, what would it be? 10 to the 12, right? And now, if you know what this is, they sell it at Costco. We usually get 1, maybe 2 if it's on sale because they're kind of expensive. You get a terabyte. Okay, now, I explained all these even though we're not going to be using most of them in class. However, I brought it up for the conversation that you have heard megabyte, gigabyte, and some of you have heard terabytes as far as storage. Okay, so I want to draw this little space here because we are not going to be using tera, giga, or mega. Okay, but I use them to show you the trend. Don't they move in trends of threes, three exponents? Because we in this class are not going to really go up. In this class of biology, we are going to go down, and it goes down in the same method. So if I go every 3 up, well, I'm going to go 3 down, right? So I got 10 to the negative 3. What does that mean? That means I have decimals. 1, 2, 3 spots. So that's how many meters that is. But what does that equal to? That is equal to 1 milli. Okay. What about the next one? Well, remember they go in 3, so it's 10 to the negative 6. And that's going to be, again, 1, 2, 3, 4, 5, and then the 6th number is the 1. What is that? That is where you get the term micro. Now, for you old school people like myself, again, we have 10 to the negative 9. However, I'll draw it out 1, 2, 3, 4, 5, 6, 7, 8, 9. Apple made one of their very first iPods with them, and I used to have it very small, skinny, and they used to call it the iPod Nano because it was Apple's way of saying it's small. And so all these terms of megabyte, kilobyte, terabyte, nano, my iPod Nano, micro, you can see that these words we've used in our everyday life. However, these are standard measurements. Okay, so you can see we go up in 3s and down in 3s. So if you can count, you can do this. Okay, and we'll go over it more in class again, but I wanted to give you the explanation for it. Okay, so now where it says, galaxies and all that, we're not going to measure the galaxy. Oops, that's crooked. We're not going to measure the galaxy and all that in forms of centimeters. That's too many zeros. That's ridiculous, right? That's why we have giga and tera and all those other ones, right? Okay, so that's all I'm going to do today. Today is going to be, I try to keep it nice and short and sweet. We're going to use this for our class discussion. We're going to take a poll, and from here you will say, you know what, that's nice. I'd rather you have me in class and I think I'll work better. Or, you know what, I like this because then I can go back and watch it again and I understand it, and then I have the opportunity to talk to you in class. I hope this has been helpful for you guys, and I will see you guys soon. Have a good one.